Hi, so we're going to look at naming alcohols. Now, the biggest thing about this is same ideas we've been doing for naming other compounds, except that we want to start from the side that's going to get us to the OH group the fastest. So if we look at this first example, we want to start on the right side of the molecule because we can put the OH in the 2 position. So once we do that, we should number our parent chain so that way we know exactly where everything's going to go. So if we start on the right, it's 1, the OH is going to be in the 2 position. We'll have a chlorine in the 3, a methyl group in the 4, another chlorine in the 5 position, and then the 6th position is our end of our chain. And so that tells us that the compound is going to be hexane. We change it to hexanol because of the OH, so let's just write that. We also have to give the position of the alcohol, right? So since it's on carbon 2, then that means we just put the 2 in front of the hexane, which is now the hexanol. And that's going to tell us the position of the OH. Now, we have these 2 chlorine groups at the bottom. So we want to say where they're at. They're in carbon 3 and 5. So we'll just put those together. So it'll be 3, 5. And then we can use the prefix di to show that there's 2 of them. And so it's dichloro. We also have a methyl group here in the 4 position. So it'll be 4-methyl. And now, everything that we have here in blue isn't part of the parent chain, it's our substituents, and so we just want to alphabetize those. The biggest thing, though, that you want to be careful about is in the dichloro, make sure we alphabetize it by the C, not the D, because it's the root word, not the prefix. Alright, but C comes before M, so if we put these all together, we're still going to get the 3,5 dichloro, 4-methyl, and then 2-hexanol, which we don't alphabetize because that's our parent chain. And that's our name of our compound. So even if there's a lot of groups, as long as you're systematic, you'll be in good shape. Alright, the next compound, same idea. The only difference here is now we have 2 different functional groups, right? We have our alcohol and we have our alkene. And we're going to see how we handle that. Alright, so let's start. The first thing you should do, find the parent chain, number from the side that gets to the OH the fastest. So I think again, we're going to start on the right. So do we compound with the 1 position on the right, the OH in the 2 position, 3, 4 as we go across, 5 is the other side of the double bond, 6, 7. So remember, the OH is going to be in the 2 position, and the ending of the word is going to still be OL, right, because of the alcohol. The little wrinkle that we have in this one is the double bond changes the AN in the middle of the word to EN, right? So when we had hexane, it became hexene when we just did double bonds. And remember, we use the first number we get to in the double bond, so in this case it's a 4. So let's just put a 4 there so we know that we're going to have to use that to show where it's at. Alright, the last thing we have is we have the bromine in the 3 position. So it's 3-bromo. And now we just got to combine them. So 7 carbons is heptane. So let's do hep. And then here is where we're going to insert the ene. And now we want to explicitly show where the OH is. So we'll put 2-ol. Okay. And this is going to show where the alcohol is. Okay. Now to show where the double bond is, we're just going to put that in front of the hep. So it's 2-heptene, right, telling us that the double bond's in the 2 position. And then lastly, we'll just put the 3-bromo in the front, because it's our only substituent. And so our name is 3-bromo, 2-heptene, 2-ol. Alright, so as long as you're systematic, you'll be in good shape. Alright, the last one, if you guys remember, what we want to do is look at that there's a ring, and the prefix for a ring is cyclo. So anytime we have a ring, we're going to use the prefix cyclo. And then after that, we just count up the carbon. So it's 1, 2, 3, 4, 5, 6. So we get 6 carbons is cyclohexane. And remember, we change the E to OL to show that it's an alcohol. Right, so we're going to make that carbon 1, 2, and then 3. And since on a ring you can pick any position to be the first one, we'll put the alcohol in the first position, and then we can put the methyl group in the 3 position because we get to it the fastest going clockwise instead of counterclockwise. And so our name becomes 3-methyl cyclohexanol. And you don't have to put a 1 here because in a ring, alcohols, we could put them in the first position. If we had other groups and it wasn't explicit on where the alcohol was, then we would. But in this case, we didn't have to.